Welcome to part 2 of the Apache HVAC New Features V2012 presentation.
First off, let me just start with you see the new interface, looks a bit different than the old one, but pretty much the same stuff going on. Shouldn't be too hard to come up to speed on this. Probably the main thing is we have toolbar organized now, sort of with the boilers and heat sources on the left, then the air-to-air heat pumps, then our new heat transfer loop, the water-to-air heat pumps that are associated with that, then all the chilled water and cooling-related things, dedicated water-side economizer types, which is kind of an older model that we're not using as much anymore since there's the integrated water-side economizer and the chilled water loops. There's the DX types, unitary cooling system types, and then all the room units, the radiators, chilled ceilings, direct acting heaters, finally then the coils and air-to-air heat exchangers, humidifiers, spray chambers, fans, damper sets, and so on and so forth. You'll see some of these have a slightly different symbol than they used to. And then finally we have the library dialog. So I'm just going to go ahead and open a blank file here. You don't need to save that. All right, so if we start from scratch and we just have, first off, I have a simple model that I'm working with, nothing too fancy. It's got a few zones, and I've assigned these to a group called HVAC 1 just so that I can assign them readily in Apache HVAC. If I go back here, go to the library, open that, you see, again, I have folders. I can collapse these folders and look at what's in. I have some more advanced systems, which are the sort of partially auto-sized systems. When we have the auto-sizing for the room units in there, these will move to the standard category up here with the larger set of systems. We have the 90.1 baseline systems in a separate folder, and we have the sort of simplified wizard systems, the old stuff from a couple of years back is in there as well, and those are now multiplexed for anybody who likes using those. There is one thing that just says prototype plant equipment and so forth. This is the same equipment that is included in every one of these other predefined systems. So if you want to just load that into one of your own systems, you can do that. See, there's no airside network there. There's some things separate for Greenmark for those who are in Singapore and doing that. And then there are a couple of locations for user exported systems. So if you have exported systems to the library, then they will show up here in this folder. That's sort of the standard library location that's co-located with the software installation. And then you can also import systems from any other location. It could be any project and so on and so forth that you previously created a system in. So it's quite flexible. I'm just going to go ahead and bring in a copy of System 5. And so we got a VAV system there. And it's now a drag and drop process. Oh, and I guess I didn't really cover that. You know, once we choose that system, then we have a number of choices, as I said over here, about what do we want to bring in. For example, do I want to bring in the heat transfer loops that are unique to this system, just referenced in this system, all of them or none of them? And so that's sort of the set of choices that I have there. And so if I look in here and look in chilled water loops, you can see that since this was the first system that I brought in, I had nothing else yet. The default was to bring in all of that plant equipment with that file. So if I don't want all of that to come in when I bring it in, I have choices about that. Similarly, I can choose whether I want to bring in all these profiles and things to my project with that. So these predefined profiles come in with it. All right, moving along. I mentioned the new containers. There's the sort of system container. If you click the bar at the top, that selects the entire system, and you can use that to drag the whole thing around. Again, you don't have to go to a move tool on the toolbar or anything. You can just click it and drag it. If I double click it, I then get the name and renaming dialog there, which is handy just to quickly name these things exactly what yours is. We'll call this HVAC reheat demo. And in the version about the beginning of next year, if everything goes as planned, this will actually be the access point for the new system parameters dialog, and which will completely replace the loads data spreadsheet and all of that with a dialog that is an overlay for each system and gives you the opportunity to do all the editing of this stuff from sort of a plain English dialog with tabs for sections of the system and so forth. But we're not there yet. So back to the present. Like the system container, the multiplex has a new container or frame unit. And so if you double click on the green top of the green frame, that's how you get to the edit multiplex dialog. I'm going to go ahead and assign the group of rooms from Air Handler 1 group. And again, I got some choices about what I want to do in terms of replacing what I selected on the list. So I've got those in my system now, and I'll go ahead and save that system. And we'll just say HVAC demo. And just to go ahead and work through the sizing tools that are now on the toolbar. The first one gets you the system schedules dialog. That's all the same options up here as before, so no changes there. We've got some new options coming, so in the future, the next feature pack, look for some new tools at the bottom for the automated assignment of alternate schedules and profiles, making this a little bit more fluid process when you do have zones in a mixed-use building or something that are operated on a different schedule with different set points. Anyway, for now, we're just going to go on from that. The system parameters dialog is also accessible from within the Apache HVAC. This is now generating a new spreadsheet for this HVAC demo system that I just put together. I've got most of the same choices that I had in this dialog in the last version, with the exception that there's a new design supplier temperature. And what's important to note here is that my design supplier temperature can be different than these temperatures for the coil leaving temperatures. So for example, I might want to have a minimum cooling coil leaving temperature of 50 degrees Fahrenheit for the purpose of dehumidification. I might want, say, a 10-degree maximum reset, which means that that can be reset up to 60 degrees. I might want to size my zone airflows according to a cooling supplier temperature of 55 degrees, and I might want to ensure that the coldest air leaving the air handler is actually 54 degrees. So I'm assuming between these that there's 1 degree of temperature gain between the air handler and the actual diffusers in the zones. So I'm sizing for a warmer temperature than is leaving the air handler. And I'm also assuming that in dehumidification, I might be driving the off-coil temperature of the cooling coil down to 50, but I'm going to immediately warm that up to 54 before it leaves the air handler. And this will never go below 54 in the case of the resetting the cooling coil temperature downward for the purpose of space conditioning. In other words, for meeting loads as opposed to dehumidification, these coils won't fight each other. So some new sizing tools in there. There's the supply fan minimum flow rate that I mentioned, defaults to 20%, and that means that in the middle of the night, 3 in the morning, system comes on because one room needs some heat, that this will force the system fan to run at 20% of its maximum flow rate, depending on what you put in here. Okay. The rest of this is all pretty nearly the same as it was before. There's a slightly new improved calculation in the spreadsheet with regard to the active chilled beam induced air ratio. So if you do a bunch of stuff with active chilled beams, or there's also a new system for 4-pipe active beams. If you do those kinds of systems, you might want to look at what's now in the VE 2012 version of the loads data spreadsheet. So we'll say OK to that. It's going to apply the values and close that for me. And the next step would be to go to the room and zone level sizing. And I'm going to go ahead and just run that to show you that what it does is it then takes me, and we'll make this, just rename that. And you can see that this is defaulted to the system that I was looking at in Apache HVAC. 5 systems in my project, but this selector has just defaulted to that one. I can run this now for any one of these systems I choose from here. So I don't need a thing called proposed.asp unless I am doing a performance rating method project and I'm using the performance rating method Navigator. So outside of the navigators, I do not need that. The system prototypes and sizing Navigator is still there for Apache HVAC if you choose to use the Navigator, and that one still uses the proposed.asp file as sort of the target. Whereas from the toolbars in Apache HVAC, they know which file you had open in HVAC, and it defaults here to that target. So we'll go ahead and let that run, and in the meantime, I can tell you about a couple other features. I mentioned the new drawing controls, so we'll show you some of that in just a few seconds after this is done. And we have the tools just updating the values in the spreadsheet right now. Okay, that's done. We're back to the HVAC view. We'll go to the next step in this dialog. We ran the zone level sizing. We'll now go and click this. That just allows us to access those spreadsheets if we do want to access them. And as I said, we can go in and change things in there. And I just want to point out a couple new things in there. You'll see, first of all, top of column P, that shows you the version number so that you know that you're in the new spreadsheet. If you look at the system tabs, you'll see that there are a number of gold headers, and those are there intentionally to draw your attention to some of the things that are new in the current release of Apache HVAC. And so there are a number of new things in there just so you can find them, help you find them. There are a few new controllers and things like that. Again, just drawing your attention to those things in case you're interested in making sure you take advantage of them. And I'm going to go ahead and close out of that, come back to HVAC, continue my sizing process. So I ran the zone level sizing. It recorded values in the spreadsheet, accessed that. I'm going to go ahead and assign that data from the spreadsheet to the system. Okay, that's done. So now if I look in any one of my controllers, I now have the auto-sized values in there as evidenced by the green values. And as before, I can do single values, or I can shift-click and look at multiple values in a table view like that. And nothing really new there, but it's just handy to know. And so moving along in the new features, let's see, why don't we finish the sizing process? So we just did and just add this there. We did the zone level sizing. Again, in the system level sizing, we're now going to size boilers, chillers, fans, and so forth. This defaults to the system that I had open. But this could be any system. I could say, nope, I want to go size this one right now. Or I could run this multiple times and size several different system files. So this is just pointing to a file which may have any number of systems in it. So go ahead and calculate. It's going to run the sizing run again, and this time to deal with those boilers, chillers, coils, and any other sort of water side equipment, as well as fans. And for those of you not familiar with it, the fans and coils used to be have an update from the loads data spreadsheet, and the only time that applies at this point is when you have a baseline system for the performance rating method that will adjust the efficiency values and the pressure values for the baseline supply fan to ensure that you have the properly allocated baseline fan power for a baseline system in the performance rating method. Outside the performance rating method Navigator, there is no influence directly during the system sizing run. There's no influence on the fan or the coils at this point in time. So all of the coil sizing is done directly from the process that we just went through, as is the fan sizing. So if I go in and look at this DX coil, for example, it's now got these values, and as I pointed out before, these are now the design conditions for the design sizing of this coil, and you can see that sort of here's the rated capacity at these, at the rated, here's the capacity at the rated conditions, and this is derived from what I've got in the types dialog as defined for this type. And then here's the design capacity, which is derived from the rated capacity and the new design conditions that actually were seen during the sizing run. So this has gotten to be a more sophisticated tool for DX sizing. And as I said, the sizing for heat transfer loops works, and water-to-air heat pumps works the same as this, except that there's both a cooling coil and a heating coil, as opposed to just a DX cooling coil. And in that case, they're connected to the water loop heat pump. All right. And as before, there are the sizing reports, and now you can access those again directly from here. And so you can go right to this, say generate the report, and then scroll down here, and you have all that sizing information for that system, and including zone level details and so on and so forth. So that's, again, just to have that tool accessed from within Apache HVAC, it's just a little more straightforward process. So we've just gone through setting up and sizing the system for this. Move on to the next set of features. So I mentioned the new heat transfer loop. I'm going to go ahead and just open a new file and bring in an appropriate system for that. And so we have, this will be one of the system type 9, which sort of the baseline one, the basic one is a fan coil system. This is 9B, is dedicated outside air system with water loop heat pumps. So I'm going to go ahead and import that. And you see that in the coil dialog, I have now a water loop heat pump selected there and heat transfer loop selected there. So this, I can actually choose in the coil dialog which water loop heat pump definition do I want, and then which heat transfer loop do I want that to be coupled to. So if we then look at those devices on the dialog, I'm actually going to work backwards from the coil. So let's go to the water-air heat pumps. These are defined in terms of types. So I'll have a list of types here. I've just got one of them defined. Go to edit that. And again, I'm looking at something that's very similar to DX cooling dialog, only it has both heating and cooling. So I have some rated conditions and a COP at those rated conditions. Then I have performance curves to choose from, and I can choose from curves for water loop heat pump or a groundwater heat pump, some industry standard curves. Again, in future versions, we'll start to add more curves to this. Otherwise, this is a pretty straightforward dialog, and it has a model description here that just includes the definitions for all of the shorthand variable names that are in the dialog. Then if I go to the heat transfer loops dialog, we have quite a bit more going on here. I'll open the one heat transfer loop that I have defined. And by the way, it's actually coming along very nicely. We have a bit of waterside graphic interface that's coming fairly soon. And so either later this summer or this fall, there will be at least an initial waterside graphic interface. So you'll be able to see more of this stuff in a graphic format and have a more intuitive way of accessing it and understanding how it's all laid out. So on the heat transfer loop then, we have tabs. We have 5 tabs here within the dialog. The first tab covers the general loop parameters from distribution losses to oversizing factors, which is an oversize the flow rates and so forth in order to meet whatever design temperatures you have for that loop. You have a number of options about, for example, the principal equipment for sizing. This is the new concept in Apache HVAC, where you can nominate something to be sized sufficient to cover the entire load, and then you have other things which are sized at some fraction of that, so that those items can, for example, be first in line to try to address the load, and then ultimately whatever this item is sort of your backstop to make sure you do have enough capacity to address your auto-sized loads if you choose to go that route. So You can select on the heating side among a heating equipment set, which should presumably be boilers or something roughly equivalent, a water source heat exchanger, or an air-to-water heat pump. The air-to-water heat pump is the same model we've had before, nothing new there. The water source heat exchanger is quite a new thing. If I select that, you'd see that both this one and this one will change, and I'll first talk about the other one. Over here we have, on the cooling side, we can reject heat either with a cooling tower or fluid cooler, and or with water source heat exchanger, and we can nominate either of those to be the principal device for sizing. So if I go to the water source heat exchanger, it changes both of these. It assumes I want to use the same water source heat exchanger for both. I could change one of these back to cooling tower and fluid cooler, for example, if I want to have a sort of a split kind of approach to this. And we could go back to that. Then we have some new facilities for the sizing of the capacity on the loop, so we can go with auto size values. We have sort of a current default value. We can override the auto size values and put in our own values and maintain the auto size values, so we have some more flexibility with how that works. Again, the black A next to the dialogues means that these values have the potential to be auto size. And we display the loop flow rate down below that's associated with those values. By the way, we also display the loop flow rate now in the first tab of the chilled water loop dialog, which is something that wasn't there before. It was just only in the chiller dialog. Now it's there on the first tab. So there's loop configuration, primary, secondary, pumps, choices for that. If I go to primary, secondary, I get a different set of choices. I can then, for example, go between constant speed and variable speed on my secondary pump. In temperature control, I have a heating section and a cooling section. And as with other loops in Apache HVAC, I have control over both the design temperature and also some set points. So in other words, I can size the loop capacity and flow rate for a design temperature of, say, in this case, 10 degrees Fahrenheit for heating, and then I can say, well, actually, I want to, control that thing either with an outdoor reset, or I want to have some constant thing where I'm going to control it to some value, say, I might even try to control it to something much higher, warmer, or something like that. This will be more intuitive if we go into, oops, I didn't put anything in there. It's, sorry, it's complaining I just didn't enter a value. I'll just switch back to, we can also enter a profile, so you could choose, you could make any profile here to control that water temperature. And I'll explain this a little bit more on the chilled water side, since it's a source of potential confusion. It's a little more obvious on the condenser loop how that works. So I'm going to go back to the reset, and so we've defaulted this. The most common thing would be an outdoor temperature reset, wherein as the outdoor temperature varies between 20 degrees and 50 degrees, we're going to reset this loop temperature between 68 and 53 degrees, and as opposed to just using the fixed 68-degree temperature up there. Again, there's a temperature difference here, and there's something new here. You'll see this value, the design supply water temperature on the cooling side, is the field is grayed out, and we have a little pop-up sort of tooltip here, and it basically is telling you that this value is going to be derived from another part of the dialog, and tells you where it's coming from. And it's in blue to draw your attention to the fact that that note is a dynamic note. So when you make choices on the first tab about what the principal device is here, that this device or this device will be determining in that dialog. So you see in this dialog, if I select water source heat exchanger, this one is not the principal device, so it's not going to drive it. But if I go into heat rejection, I've got a blue value there. This is selected as the principal device for sizing, and so this is coupled back to the temperature control tab. Okay, so we have a connection there that's described by the tooltips. Again, we have a type of reset we can put in there, or we can put in some profile or something, or just set that constant. and we can control that temperature set point. And because this is a heat transfer loop, because it has both heating and cooling functions, it basically has a sort of a dead band in which the temperature is allowed to float, and kind of an upper limit on the cooling side and a lower limit on the heating side as a resource then for other devices to put heat on the loop or take heat off the loop. The heat acquisition tab is very much akin to what is in the hot water loops dialog. You have a number of choices about what you want to use to acquire heat. As I mentioned in the diagram, you can have solar hot water heater. That's nothing new. It's the same dialog that we've had in there before. Pretty detailed solar hot water model. And then you can choose to have heat recovery. This has some new features in it, so I'll take a moment to explain those. The basic model, as I described before, is a percentage of heat rejection from the specified condenser water loop. So if I say the type of thing I'm going to grab as a source is a condenser water loop, and I'm going to select, say, this chiller and its condenser water loop as a source. And in this case, I could actually have multiple sources. And you'll see the list has gotten shorter now because I've actually used the other one already. So I can grab heat from the condenser loops for both of those chiller sets if they were both active in this model. So I could actually have two chilled water loops with two chiller sets and two condenser water loops, and both those condenser water loops could have heat recovery going to this heat transfer loop. Then I can opt for a heat pump, and this again is the simple model. Since I have multiple loops here, I just have a simple fixed COP value. If I go to the more sophisticated model of the explicit heat transfer, it's right away going to tell me that I'm going to reset the source data because I can only have one source. And so once I change that, I now have the ability to choose just one of those sources, but now I have an explicit heat exchanger between that condenser water loop and this heat transfer loop. And again, I have the choice of whether or not I want to add this water-to-water heat pump to upgrade the heat. Say my condenser water loop is 80 degrees, and I want to be putting 120 degree heat on this loop, especially if it's a hot water loop. I'm going to want that heat transfer loop. I might be more likely to get away with just a heat exchanger. And as I described before, this model basically gives you two data points. So I'd specify the delta T at two different data points for the thermal lift between the two loops, and then specify the COP at those two thermal lift data points. All right, so I talked a bit about the water loops, the heat transfer loop and interloop heat exchanger. The next thing on my list is the air-to-water heat pump. Again, that's very similar, essentially what we've had here before. You'll notice that there's a percent of the auto-size loop heating capacity, so that's a common feature that you'll start seeing. And this is so I'd say, oh, if I put in 40 here, that's 40% of the total auto-sized capacity, okay? And that's saying that it's not going to be subtracted from the loop capacity. It's just a fraction of that loop capacity. And again, this has a model as we've had before. You can enter COPs and so forth relative to the outdoor temperature and capacity. Finally, there's the CHP as there has been before, and just the sequence ranking in here. And then the heating equipment set. The heating equipment set is exactly the same as you've seen in the past in the hot water loops dialog for adding boilers and so forth. And there's the boilers dialog, nothing new here. That's the same as it's been, so you can add additional boilers, and I'll just remove that one. So, okay, there's all that. And then we have the water source heat exchanger. The water source heat exchanger is a completely new piece of this. This allows you to have one heat exchanger, and we have these radio buttons here just for your convenience, sort of to give you the idea that what you're doing here is defining one piece of metal, one device, which could have If you go for constant, you have the same sort of source water temperature on both heating and cooling conditions. Whereas if I go for profile, and I put in some profile here, I haven't actually defined one, but let's just say I did, and I had something that varied over the course of the year. Now I can actually have slightly different source side entering temperatures for the heating and cooling modes of this. So I could say, in the winter, I'm actually going to have an entering temperature here of, say, 50 degrees, and in the summer, I'm going to have some warmer temperature. Maybe I'm accessing a pond or a lake or a well or something, and it's actually going to be 68 degrees in the summer, or it's pretty warm, say 62, 64. So you can do those kinds of things, and then again, you could also have a profile that describes how the source water temperature varies over time. And again, if we go back to the constant value, that forces these back to constant, so it's the same on both sides all year round. Then approach values and things like that. This assumes you get the same piece of metal, so you're setting it in terms of the heating or cooling sort of selection of the device, but you're not really setting it for both of those independently, because you don't really have two different devices. But you can change the source side delta T, or which is linked to the source side flow rate. You can say, oh, I'm going to adjust the source side flow rate, and that then will adjust the delta T for you. Those are linked, and the little bar there is just indicating that. Then we have the heat rejection tab. As I mentioned before, this has the same options as for heat rejection on the condenser water loop associated with the chiller set. And so you have a cooling tower with heat exchanger versus a fluid cooler. That gives you some different options here. And again, with the fluid cooler, you can operate wet and dry, or just dry. If you go wet-dry, then you have a transition point at which it switches from wet to dry to prevent freezing and so forth. And you'll notice on the heat transfer loop, there are no chillers. It's not a chilled water loop, but it does have heat rejection. In the future, we will have some more sophisticated ways to couple that to other loops. But presently, the heat transfer loop is meant to operate when there is a water-to-air heat pump attached to the loop and coils attached to that one or more heat pumps. And so that's, right now, it's basically focused on water loop heat pumps. But as I say, in a future version, you'll be able to put coils and chilled ceilings and radiators or whatever you want to put directly on that loop. And at some point, you'll also be able to use it as a plant-side only resource, wherein the heat transfer loop is used simply to move heat between other loops and not actually connected to any load-side components at all. So on the chilled water loops dialog, if I just open, well, let's see, let's go to this last one here. Most of this is the same, but you'll notice that at the top, we've got the capacity and then the chilled water loop flow rate listed right on the first tab of that, just so that you have the collective flow rate. Before, we had the flow rate for each chiller in the chiller part of the dialog. So now you see the total flow rate for the loop right there. And of course, that you would have also seen in the coil dialog when you connected a coil to this loop. And now we're just putting it up front there so you don't have to go looking for it. The pumps and other resets and so forth are pretty much the same there. And again, I wanted to mention here in the heat rejection side, just to clarify what I was saying before about design temperatures versus set points, you have some outdoor design conditions, and then you have a design condenser. You might say this is the condenser loop supply temperature, otherwise known as the condenser entering temperature, the temperature coming into the condenser tube bundle, including heat gain from the pump on that loop, and including contribution from whatever devices might be contributing to the heat rejection on that loop. Then separate from that design condenser entering water temperature, there is this set point, which can be, again, a timed profile, or it can be a constant value. And in this default, this is kind of illustrative here, the design value is 85 Fahrenheit and the sort of default set point is 70. It means that this is going to try to maintain a 70-degree water temperature entering the condenser tube bundle whenever it can. And when it's unable to do that because of outdoor conditions or loads or both, then this condenser temperature, water temperature, is going to rise up towards the design value. And if this is properly sized, it should not ever exceed that design value. The chiller set part of the Dialog is the same as it's been in the past. In the pre-cooling part of it, which as I mentioned is ahead of the chiller set, this is normally on the secondary return, but you can also put it on the primary return, your choice. This has its own set of non-auto-sized outdoor conditions, and the assumption here is that whatever device you set up for pre-cooling might be intended to operate when, for example, in shoulder season, when the conditions are a bit more mild than the midsummer design condition for the chiller set. So you might have a separate cooling tower or some other device, or in this case a water source heat exchanger that is set up to pre-cool that return water from the coils or chilled ceilings or whatever it's coming back from, and address that load as much as it can before that even goes to the chiller set. And if you have a water side economizer operation, then that will use a separate, that will use the cooling tower that is associated with the condenser heat rejection, or in this case a fluid cooler associated with the condenser water heat rejection. So this fluid cooler is on the condenser loop, rejecting heat from the chillers using the water side economizer sort of operation. And on the pre-cooling tab, there is a separate device defined to pre-cool the water coming back from the load side. And again, this I could add an ambient device as well as the water source heat exchanger. And the ambient device, I get to choose between cooling tower and fluid cooler. So in this case, I would have a second fluid cooler in addition to the one I've got over on the condenser loop. And this fluid cooler can operate pretty much the same parameters, same design parameters, so on and so forth. But I have this parameter up here for the auto size percentage of the chilled water loop capacity. So this device can be seen as sort of a smaller, cooling device on the loop that's attempting to do the same thing as the chiller before the load ever gets the chiller. All right. That's probably enough for the water side, so I'll take a few minutes just to demo some of the other things in terms of editing systems and moving things around. I mentioned before there are new drag and drop copy tools, so I can take this, just click on this object and move it anywhere like that, or this object I can hold the control key and move it anywhere like that. So again, just faster because you don't have to go up and grab the, we'll just take this guy and put it back over here. You don't have to go up and grab the move and copy tools off the toolbar, although they are still there. Then also of note, if I hold the shift key, I can drag this control box around without changing the connections of the controller. So I can say, I really want to add another one down below this. I'm just going to move that one up there. Or I could decide, I actually want to move this point. So I'll select that controller and take this control point, and I can drag that to somewhere else on the network that I actually want to control some other node somewhere else with that same controller. So maybe I want to make a copy of this controller, and I'll just make a copy down there, and I'll say I want to use some similar parameters, only I want this thing to control some other device that I'm going to place maybe over here. I'm going to put some pre-cooling or preheating coil out there, and I want this to sense some other value on the system. I can move the sensor node around, or I could just take the whole thing and say, no, I'm actually going to sense something out here, and let's just drag this outside. Oops, I didn't hold the shift key first. Let me do that one more time. Okay, so now I've used an existing controller from within the multiplex, but I've dragged it around and modified it. I've still got everything that was in that controller. If I somehow saw that as a useful starting point, I would want to get rid of this MC:, because that says that it's a multiplex controller and it's going to be coupled to the loads data spreadsheet based on that. And it's no longer even within the multiplex, so that doesn't make any sense anymore. But you get the idea. You can start from an existing controller. You can move things around quite flexibly now. That's a good bit easier to use than it was before. Other things, the drawing tool. We'll just go to a blank canvas here, save anything, and just say I were to place, let's put an inlet here, an outlet here, and we'll put in a fan. Okay, we're just going to do a couple of very basic things. We'll drop a heating coil on here. We don't have any heat pumps or anything. We'll just, okay, put a hot water loop in there. Put a heating coil in there. Okay. And just to give you an idea of how this would work, and we'll put that there. And whatever, we'll call it some room. Okay, so the drawing tool. I now have this tool, network drawing tool, which I can use with this pencil to just draw from one component to another. And then if I want to put a cusp there, I put a cusp there and draw down there. I can draw from there. And let's see, I might want to put some economizer thing or something there. So if I connect there, it immediately says there's going to be a junction, but it doesn't know what that junction is yet. And I might want to put another junction from there and go there. And now I have little question marks on the junctions. I can go in and select which way those are going to go. And similarly here. So you get the idea. So the drawing tool is actually quite quick if you want to sort of work from scratch. And if I was to add another connection there, you can see it automatically puts the junctions in, and it asks me, well then, which way do you want that thing to point? So that's probably enough of that. I'll now open this up to questions. I hear somebody on the line there. Go ahead.
Yeah, Timothy, it's Chris here at Phoenix. I have a question.
Yeah, sure. What's your question, Chris?
Just looking at the water side economizer tool, which was available in previous versions. There's an option there to specify that the economizer might operate only when it can meet the full load.
Yes.
And then if we look at the heat transfer loop, the new heat transfer loop, it has a cooling tower loop, which allows for some, cooling to meet the load. I'm just wondering, what's the difference between the water side economizer and the cooling tower on the heat transfer loop? The cooling tower and the heat transfer loop doesn't allow you the option of operating it, depending on whether it can meet the full load or not. And I'm wondering, is there any real difference between those two tools?
Fundamental, yes. The difference is that, as I mentioned earlier, the water side economizer is using the same cooling tower as is being used otherwise to reject heat from the chiller condenser. And therefore, there's a question of whether you want it to be an integrated water side economizer, which means that when it cannot meet the full load, as long as it can still do something useful, the chiller set will turn on, and the water side economizer operation will continue as long as it can actually make colder water than it's receiving. And so as long as it can do something useful to reject part of the load, and that collectively it's not taking too much of the heat rejection capacity away from the condenser tube bundle, at which point either the outdoor conditions become too severe or the load is too high, it will no longer be useful. It'll end up constraining the chiller or something, or just not be returning significantly colder water, at which point it'll automatically shut down, and now the chiller is operating normally with that same cooling tower not connected in water side economizer mode, connected only as heat rejection for the condenser loop. If I tick this box, there will not be integrated operation. In other words, there will be no overlap between water side economizer mode and chiller operation. at the point at which the water side economizer mode can no longer meet the full load that's present at the time, then it will close down completely, and that tower will serve the condenser loop only, and the chiller set will be the source of cooling. Now, if you go over to the heat transfer loop, by contrast, on the heat transfer loop, heat rejection there is no chiller, right? There are a number of water loop heat pumps that may or may not be on the loop. And again, as I've mentioned in VE 2012, in this version, this loop requires the load from the water loop heat pumps or water to air heat pumps in order to operate, because it doesn't accept other types of load side equipment yet. So, if you will, the condenser side of those water loop heat pumps is more or less the same thing as the condenser side of the chiller. However, there's no option for this cooling tower to sort of get in between that heat pump and the coil on the zone side. The coil is connected by a DX, a direct connection to the water loop heat pump, and by refrigerant and not by water. And so therefore, there's no way for this device to cool that water in a sort of economizer mode, or to cool that fluid in an economizer mode before it gets to that heat pump device. So the heat pump, which is equivalent to a lot of small chillers out in the zone level, are just dumping heat on the heat transfer loop. The heat transfer loop is then effectively operating as a condenser water loop, and there really is no sort of water side economizer mode. However, the heat transfer loop can, of course, move heat from a zone which is in cooling mode to another zone or zones which are in heating mode, which can extract heat from the very same loop. So it has the common loop functionality similar to a variable refrigerant flow system or VRF system. Does that answer your question pretty well?
That's great. Thanks, Timothy. Yeah.
Sure. Other questions?
Hey, Timothy. This is Corey with TLC. I was wanting to find out how do things change now with the heat transfer loop on how you would set up the VRF system?
The short answer is it doesn't yet. And that is that this, for a couple of reasons, this is not a good fit to modeling VRF systems, even though it has this common feature, but because it's presently constrained to requiring a heat pump on the water side, you could probably develop a sort of workaround method that would use heat pumps on this loop and use this as the common loop, and that would give you some advantages, but you still have then a water loop with pump power and flow rates and all kinds of stuff, and you can zero out the pump power, but you're not actually going to get a whole lot of advantage from this device as compared to modeling it the way that's currently in the appendix of the user guide. That said, we are working on an explicit VRF model, which will be DX cooling directly coupled with a heat pump so that they can directly exchange heat as a common refrigerant loop and reject heat either through a condenser coil, outdoor condenser coil, or some zone condenser coil. And that way it'll actually know that it's rejecting heat at the room temperature versus rejecting heat to the outdoor condition.
Do you expect that to be part of the feature pack later this year, or are we looking farther out for that?
We're looking at about the end of the year, beginning of next year version for that.
All right, thanks.
Sure, you're welcome. Other questions?
Timothy, with the ability for the VE to export loads to Gaia GLD for ground source heat pumps,
Right.
Does the new functionality of VE 2012 allow you to now re-import that and assign the ground loop temperatures to your heat transfer loop in order to assign efficiencies to those ground source heat pumps?
Not yet, no. At this point, you're still modeling the ground source heat pumps completely in the Gaia GLD tool, and whereas you can bring the results from that back in and view them in Vista results, we don't yet have a means of bringing that back in, and ideally we'll want to have that coupled at every time step, so you can actually model a backup boiler or backup cooling tower within Apache HVAC, but we don't have that yet.
Thank you.
Other questions?
Timothy, Corey again. Have you guys looked at anything about creating a better way to implement annual schedules for buildings that don't operate year-round? Maybe they only have a seasonal operation.
In other words, once you create an annual profile, you're looking for a more an easier way to implement that, is what you're describing.
Right, instead of having to go back through and, not only creating annual profiles for every profile that you're going to have to reference, but then also the process of having to reassign those.
Yeah, it's a bit tedious, admittedly, and so if you have a school or something like that that's got a different summer operation or similar, then it's a bit tedious. I don't think that we yet have a solution for that, but we are actually beginning that conversation, because it's come up a few times recently. And because we are revamping the way that schedules and profiles are created for this version at the end of the year / beginning of next year, we're going to simplify the whole way that profiles are treated in Apache HVAC, and with respect to room temperature set points and schedules, and I think that will help considerably. And so hopefully in the process of that, we're going to create some means by which you can have choose to have an annual profile, which is faster and easier to set up and applies to all the places where you've already got those profiles referenced, so you don't need to go in and manually change them out.
All right, thanks.
Thanks everybody for attending. Hope this was helpful and informative. Again, as I mentioned before, the PowerPoint presentation that I showed at the beginning is available on our website, so you should be able to download that. So again, thanks a lot for attending, and have an excellent rest of the day. Bye-bye.